Viewing right triangle trigonometry. This can take a couple of videos here for a couple of note pages. We're trying to basically cover what was an entire chapter in geometry in a couple of videos here. So to begin with, you're probably going to want to have a calculator around. So make sure that you do that. You can pause the video, go find one, and you want to make sure that that calculator is speaking in degrees, and depending on the calculator that you have, there's different ways that you might be able to figure that out. If it's just a regular scientific calculator, you should see a little D on the screen somewhere. If it's a graphing calculator, you probably have to hit mode and then look in the mode to see if it is in degrees or in radians. Okay. So if you remember, our trig functions are sine, cosine, and tangent, abbreviated this way. Okay, we still say them sine, cosine, and tangent that way, and we write them that way, but they always have to have a something that goes with them. And so the way that they apply, for this, our triangles need to be right triangles. And we like to label the sides of the triangles that goes along with the ratio that's in the triangle. Our side names are always either hypotenuse, opposite, or adjacent. And we have to identify what angle it is that we're talking about, and it's not going to be the 90-degree angle. So you should be able to clearly identify the 90-degree angle. And then in this one over here, we'll call that theta. We like to use Greek letters in these, especially once we get to the algebra 2 level, and we'll call this alpha. Looks like a little fish there. And so in this triangle over here, where we have theta labeled, what I will usually do is I'll find that right angle, and across from the right angle, that is always where the hypotenuse lives. Okay, so I get that labeled right off the bat. And then I go all the way across the triangle from the angle that we're talking about, and that is where the opposite side lives. We call that opposite. It's on the opposite side of the triangle from where the angle is. And then the one that's left over is the adjacent. Adjacent means next to. This side is next to this angle labeled theta. The hypotenuse is as well, but it's too busy being the hypotenuse to be the adjacent. Okay? These triangles look the same, but because I'm focusing on a different angle here, well, it doesn't matter what angle I focus on, this is still going to be the hypotenuse. And then across the triangle from that angle that I'm looking at, that is where the opposite side is. And that must mean that this side over here is the adjacent. So when I make reference to opposite adjacent in a triangle, it depends on which angle it is that I'm talking about, and that's important to remember. You probably in geometry learned the mnemonic SOHCAHTOA. Okay, SOHCAHTOA is to help remember which sides go with which trig function. The purpose of a trig function is to change an angle in a right triangle into a ratio of two sides of that triangle. There's a ton of stuff behind this that we don't have time to go into right now. In the SOHCAHTOA, whenever we're doing this, the three things that go together, and there are always three things that go together, there is the name of the trigonometric function, either sine, cosine, or tangent. We can use its three-letter abbreviation. There is an angle, the focus of which acute angle in the triangle that we're actually talking about, and then there is a ratio. The ratio actually takes two sides, and that's what our mnemonic helps us remember. And we want to throw in this warning here that whenever we're doing this kind of stuff, we always want to write the equation. Okay, so let's take a look at an example. We'll draw a quick right triangle here. Mark the right angle. Let's say this angle is 47 degrees. we'll say we don't know what this side is, but we know what the hypotenuse is. Sometimes they will tell you to solve the triangle. When they tell you to solve the triangle, it means find all of the angle measures and side lengths that you don't currently know. In this case, we're just going to try to find the x. And so the place that we start here, first of all, is we identify the angle that we're talking about. So here's the angle, and then we label the sides accordingly. From the right angle, this is the opposite side. Across the triangle from the angle that we're talking about, that is the opposite, or I'm sorry, that first one that I said was opposite is hypotenuse. It's opposite of the right angle is the hypotenuse. This is the opposite side. That makes this the adjacent. And so now I look at the labeled things and the stuff that I know or want to know, and I want to know the opposite, and I know the hypotenuse for this particular angle. So I go to my mnemonic and I'm looking for which one has an H and an O in it. And the one that has an H and an O in it is the one that starts with an S. That's the so. That tells me I'm doing sine. And so the first thing I write down is that I'm doing sine. I'm doing sine of a particular angle. Which angle? Well, the angle that they gave us, the 47-degree angle. And that is going to be equal to. So sine changes the angle into a ratio. And the ratio, according to my mnemonic, is the opposite divided by the hypotenuse. So the first letter I see, the opposite was labeled x in my picture, divided by the hypotenuse, which is a 30. I want to solve for x. This says x divided by 30, so I can undo a dividing by 30 with a multiplication by 30. 30 divided by 30 is 1, and it tells me the side I'm looking for is 30 times sine 47 degrees, and that's exactly what I'm going to put into my calculator. Calculator will convert that angle into a ratio for me. Times 30 times sine of 47, and that says it is 21.9. They usually will give in some kind of specification of how far to carry that out. I should always ask myself, does that number make sense in this problem? I know in a right triangle, the hypotenuse is the biggest side of the triangle. It's a 30, so I know that it should be a number that is smaller than 30, and it is. I'm pretty confident in that answer. All right, let's try another example. Draw a new triangle in here. So here's my right triangle. I'm going to say that's 12, and this is x, and this is 21 degrees. So the process again, here is the angle for the right angle. Across from the right angle is the hypotenuse. Across from the angle that I'm working with is the opposite, and so this one must be the adjacent. And in this case, I know the opposite, and I want the adjacent. So that's O and A, and in my mnemonic, the one that has an O and an A is the tangent. So I write tan of the angle is 21 degrees, is equal to, the first letter in that TOA is an O, so that's the opposite side, which is 12, divided by the adjacent side, which is x. Okay, so it's kind of like the last problem, but the x is in a different location, so that's going to take a little bit different solving. Again, if I look at this and I'm estimating, I'm thinking that the adjacent side should probably be bigger than 12, because the opposite side is across from a 21-degree angle. That means this other angle must be like 69 degrees, and so this side across from bigger angles are bigger than the sides across from the small angles. So whatever I do here, I better get an answer that's bigger than 12. Now, I know that I could view this as a proportion this way, And an equivalent proportion, what's going to happen when I cross multiply is that two numbers are going to get multiplied together on the diagonals. So this is the same thing as saying x over 1 is 12 over tangent 21 degrees. If I cross multiply on the second one, I would get exactly the same thing as if I cross multiply on the top one. So this says x divided by 1, or just x, is equal to this 12 divided by tangent 21. So 12 divided by tangent 21 is exactly what I'm typing into my calculator. 12 divided by tangent 21, close the parentheses. I get about 31.3. That is bigger than 12. I expected it to be, so I think I like that answer. We've got several examples to go through here, so we're just going to kind of press on here. Example 3. Let's get another triangle in here. Okay, I'm going to say that's a 90-degree angle. If I label it that way, then it has to be. I'm going to call this angle theta down here and make that 21 and that 26. And in this case, I'm trying to find the angle. Which angle? Well, this angle. And this here then would be my hypotenuse, because it's across from the 90. Across from the theta is my opposite. And so this one must be the adjacent. And so what I know for this angle is opposite and adjacent. That's tangent again. So I can write that the tangent of the angle, in this case, the angle is unknown, it's a variable theta, is equal to the ratio TOA, O divided by A, 26 divided by 21. And now I need to get the trig function off of the theta. And the way that we learned to do that was with an inverse trig function. So the theta now will be the inverse tangent of 26 over 21. Okay. I get that on my calculator by doing second or inverse or shift on some calculators. And then the tangent, and it'll put a little tangent with a -1 up there, and then I'm going to put 26 divided by 21 inside, and this gives me an angle of about 51 degrees. Okay, I like 51 as an answer. It would make the other angle like 39 degrees, and so the 26 being across from the 51 and the 21 being across from the 39, that fits with the big angles, big sides, small angles, small sides idea that we have. So there is a shift or second or inverse for every one of the sine, cosine, and tangent, depending on which equation you actually end up with. Okay. Example 4, it's a little bit different twist. It's asking me to draw a right triangle where the cosine of theta is equal to 7 over 15. Okay, well, I'm just going to start by making a right triangle. It doesn't have to be drawn perfectly to proportion, and I'm going to pick an angle. Doesn't really matter which one. I'll choose that one. And what I know about cosine is that's from the ka part of the mnemonic, which means it is equal to the adjacent side divided by the hypotenuse. So the adjacent side, which is this one here, should be 7, and the hypotenuse should be 15. So in this triangle that I've drawn, the cosine of theta is 7 over 15. I could fill in other parts of that. It didn't ask me to find what theta was in this case. It just wanted the triangle. If I wanted to figure out what theta was, that would be an inverse cosine of 7 over 15. Okay? If I wanted to do that, but that's not what it asked for in this problem, so I'm done right there. Okay. And finally, so if sine theta is 8 over 17, then what is the tangent of theta? Well, the last problem kind of set me up on this. So I'm going to draw a right triangle. And I'm going to make it so that in this right triangle, I'll go ahead and put my theta up here this time, doesn't really matter. But I know that sine, the mnemonic that goes with sine is so, and so the 8 must be the opposite side, and the 17 the hypotenuse. So 17 there, opposite side is here. But it's asking me what is the tangent. Tangent of theta is TOA, that's opposite divided by adjacent, right? That's saying tangent theta is the length of the opposite side divided by the length of the adjacent side. And I know this is my opposite, this is my hypotenuse, this is my adjacent. I don't have anything for that, but this is a right triangle, and I know 2 of the sides, and so I could use the Pythagorean theorem. Okay, if I call this adjacent side x, then 8 squared plus x squared, leg squared plus leg squared, equals hypotenuse squared. So 64 plus x squared is equal to 289. Subtract 64 from both sides, and I get x squared is 225, and this square root on both sides tells me that the x must be 15, so my adjacent side is 15, my opposite side was 8, the adjacent is 15, this is what tangent theta is equal to in that triangle. So, gives me some information about the triangle, enough that I can draw the triangle, find the pieces that I need to be able to find the other ratio that I'm looking for.